Hey everyone, in this session let's check out arithmetic and statistical operations on NumPy arrays. NumPy offers a number of methods to perform arithmetic and statistical operations on NumPy arrays. We can perform addition, subtraction, matrix multiplication, division, reciprocal, and a number of arithmetic operations on NumPy arrays. All these operations work on top of one-dimensional arrays or multi-dimensional arrays. Not only arithmetic operations, we have plenty of methods to perform statistical operations on NumPy arrays too. Mean, median, standard deviation and variance calculation are very easy on top of NumPy arrays. During our coding session, we will write some code on Jupyter Notebook to explore all these methods available for arithmetic and statistical operations on NumPy array. We will also understand a very important concept on NumPy called broadcasting. Whenever we perform addition operation on arrays, the dimension of arrays should be same. However, NumPy can handle arithmetic operations on NumPy arrays of different shape as well. In broadcasting, smaller array will be stretched to match the larger array's shape to perform arithmetic operations. Here, as you can see, we have an array of 1 cross 3 and another array is of 1 cross 1. If we perform any operation, the smaller array will be stretched to match the shape of the larger array, and then arithmetic operation will be performed on top of it. Remember, as per NumPy, two dimensions are compatible if both the dimensions are equal or one of them is 1. In this case, the dimension of one array has 1. Both these arrays are compatible for arithmetic operation. Let's go to Jupyter Notebook now to perform arithmetic and statistical operations on NumPy on arrays. We will also explore broadcasting feature of NumPy during our coding session. I have created a notebook in Jupyter to explore all the methods and broadcasting. In order to explore NumPy methods, we have to import NumPy in our notebook. We will first explore the arithmetic operations and then we will see statistical operations as well. Here I have an example array named array_1. We want to add 2 in it. We can add scalar values into an array. Let's run this. You will see here 2 has been added with all the elements present in the array. Not only scalar value, we can even add multiple arrays together using addition operator. NumPy offers add method to perform the addition operations. So here, as you can see, both the results are exactly same. So we can use either addition operator or we can use NumPy method called add. Let's see how we can add 3 two-dimensional arrays together. Now, if I want to use add method to add 3 arrays together, that is not possible. Add method always takes 2 arguments. So array 1 and array 2 both have been added correctly. However, array 3 is not added. So add function only takes 2 arrays for addition. We can use either power function or exponential operator to perform arithmetic operation on an array. So we are getting square value of all the elements present in an array. We also have mod function to perform modulus operation. Let's run this program. Here, as you can see, all the even numbers has been converted as 0 and all odd numbers are converted to 1 because we are performing modulus 2 operation on each element. Not only addition, power and modulus, we can even perform multiplication, division, subtraction as well. Here we can either use multiplication operator or we can use np.multiply to multiply multiple arrays. During practice, you can also check subtraction and division operation on arrays. Both are very similar to addition and multiplication we have performed here. Let's see if we can perform reciprocal operation on a two-dimensional array or not. Reciprocal is a function offered by NumPy by which we can perform reciprocal operation on each and every elements present in a NumPy array. Now here if you see, I have two different arrays. One array has 3 elements in it, another array has 2 items. If we want to perform addition operation on top of these two arrays, it will throw an error. Operand could not be broadcast together with shape 3, and by this error message we can clearly understand that NumPy tried to broadcast or stretch the array of smaller size to the array of larger size, but it could not perform the operation successfully. Hence this error. Remember, as per NumPy, the dimensions are compatible if both are either equal or one of them is 1. In the second example, if you see, another array has dimension 1. If we perform the addition operation now, it is correctly giving us the result. What NumPy does, the smaller array will be stretched to match the size of larger array. That is called broadcasting in NumPy. Here 2 will be stretched as 2, 2, 2, and then both the arrays will be added together. We are getting result as 4, 6 and 8. Hope you have understood what is broadcasting in NumPy. Let's now check out few of the statistical operations on NumPy arrays. Mean is a method by which we can perform mean on a two-dimensional array. Mean also works on NumPy arrays of any dimension. As I have added axis equal to 1, the mean will be calculated column wise. Let's perform row wise standard deviation on this two-dimensional NumPy array. Apart from mean and standard deviation, we can also utilize variance and median function what NumPy offers to perform statistical operations on arrays. In this session, we have explored all the frequently used arithmetic and statistical functions what we can apply on NumPy arrays. With an example, we have explored broadcasting operation of NumPy. Thanks a lot for watching this video.